We're going to learn the last of our basic differentiation formulas today. And this one looks like a bit of a beast, the quotient rule. And this is the one that we're going to use when we have one function divided by another and we want to find the derivative. And at first glance, this numerator of this formula kind of looks a little bit like the product rule, where we take one function times the derivative of the other, and then we swap roles in the second term. Unlike the product rule, the quotient rule has a negative sign in the middle. So it matters what order you do this mixing and matching in, right? So this denominator of the function is going to be the one that has not got the derivative in the first term. We take the derivative of that denominator in the second term, the one that's negative. And then the denominator also shows up again at the bottom of our quotient rule, the denominator squared, not its derivative. And then we have the numerator f of x that shows up as its derivative in this first term and then alone in the second term. So we'll think of this quotient rule as being the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. So sometimes a way that people will remember this rule is if you're taking the top and the bottom and finding the derivative, then we'll remember this as the bottom times the top prime minus the top times the bottom prime all over the bottom squared. And this is sometimes referred to as the bathtub rule, because of the BT and the TB, if that helps you to remember which order things go in. Another way sometimes that people will remember this is the high function over the low function. And we can remember this as the low, take the derivative of the high function minus the high times the derivative of the low function all over the bottom function squared. So low, low. So it reads low d high minus high d low over low low. So if either one of those are helpful to you, feel free to use them. However you want to remember this, it is a good one to have memorized rather than having to always go look it up because we use it so often. All right, so here's a function that we did in class by the product rule. We rewrote this one as x to the minus 2 times sine x, so we could use the product rule. I'm going to rework this one using the quotient rule. So we're going to remember our quotient rule. If we have the top divided by the bottom prime, this was our bathtub version, bt prime minus top bottom prime over the bottom squared. All right, so we're going to find f prime of x. All right, so the rule says to start off with the function that's in the bottom, so x squared by itself, times the derivative of the numerator, the top prime, so derivative of sine is cosine, minus the top function, sine, times the derivative of the bottom, so derivative of x squared is 2x, and then all of that over the denominator squared. All right, so just a little bit of simplification. X squared cosine x, we can kind of just leave that like that. And then I'm going to scoot this 2x as a coefficient so it doesn't look like it's inside my sine function. And then x squared squared, I'm going to add those, multiply those exponents and get x to the fourth. And this is our answer. This is our derivative. And this looks slightly different than what we got with the product rule. I would encourage you to go back and look at our answer that we got for this using the product rule in class and see if you can do a little bit of algebraic simplification to verify that this is actually the same derivative. All right, this next one is definitely one that we're going to want to use the quotient rule on. We've got two functions being divided by each other. This one is actually not one that you can do by using negative exponents and turning it into a product rule problem until we learn the chain rule, which is later on. So we're going to use the quotient rule here. I've got it up in the pink box in the upper right-hand corner. All right, so we're going to take our derivative, which starts off with the bottom function. So this x squared minus 3x plus 10 times the derivative of the numerator. So times the derivative of 5x minus 1, which is 5. I'm going to have to put this in parentheses. You want that whole bottom function times the derivative of the top, so times 5. Then we've got our minus. We're going to take our top function, 5x minus 1. Again, I'm going to put that in parentheses, times the derivative of the denominator, b prime, bottom prime. So we're going to have derivative of x squared is 2x, derivative of minus 3x, and then derivative of 10 is 0. So that's our bottom prime all over our bottom squared. So we're going to need a big set of parentheses here. All right, and we are going to do a lot of simplification in this numerator. The bottom, however, if you have a big polynomial like this being squared from the quotient rule, don't try to FOIL that out. Just leave it as the big set of parentheses squared. All right, but up top, I do have some work to do. I'm going to distribute this 5 And I've kind of got two things to do in the second term. I need to distribute that negative sign, but I also need to FOIL out those two binomials. I'm going to do the FOIL first, multiplying out, and then I'll distribute the negative at the end. Okay, so we're going to do our first, outer, inner, last, and then I'll put the negative on all those terms. Okay, so what do we got here? I'm going to distribute the 5 through this first set of parentheses. So I'm going to get 5x squared minus 15x plus 50. All right, so that's the first term. And all along, I'm just going to have this x squared minus 3x plus 10 being squared. And then I have minus. I said I'm going to distribute that minus at the end. So I'm going to keep a big set of parentheses and do my foiling here. So I've got 5x times 2x. That's going to give me 10x squared. My outer terms give me minus 15x. Inner terms, minus 1 times 2x, so minus 2x. And then minus 1 times minus 3 is plus 3. And we're going to see if we can squeeze this in down here. Now I'm going to distribute that negative through all of those terms here. Okay, I've also got some like terms I need to combine, but I'm going to save that for the end. So I've got 5x squared minus 15x plus 50, and change the sign on everybody in that set of parentheses. So we're going to have minus 10x squared plus 15x plus 2x minus 3 all over this set of parentheses squared. All right, so my final answer is definitely going to have that set of parentheses squared down there. So I'm going to copy that now. And then we'll see what kind of like terms I have up top. Okay, so I have a 5x squared and a minus 10x squared. That's going to leave me with minus 5x squared. And then I've got minus 15x plus 15x. Those two cancel out. And then I've got a 2x. So I'll have plus 2x. And then I've got plus 50 minus 3. So that's going to be plus 47. All right, and that is not pretty, but that is the derivative of f of x. Let's do one more example using the quotient rule. Here I've got the square root of x divided by x minus 3. And because I'm taking derivatives, I'm going to rewrite this from step 1 as x to the half, x minus 3. And then when I'm done simplifying, if I want to, I can change that back to a square root. All right, so I've got my quotient rule in the upper right-hand corner. We're going to find our f prime of x. So we're going to take our bottom, our denominator, x minus 3, times the derivative of the top. So we want the derivative of x to the half. So we're going to bring down that 1/2 x. Then we're going to do 1/2 minus 1 in the numerator. So we've done this a couple times before. 1/2 minus 1, 1/2 minus 2 over 2. So that gives me negative 1/2. So my new exponent for the derivative is negative 1/2. Okay, so let's keep track of where we were. We did the bottom times the top prime minus the top x to the half times the bottom prime. Derivative of x minus 3 is just the coefficient of the x, it's 1. And then I've got over the bottom being squared. All right, so let's see what we can clean up here. I've got this x minus 3. And if I simplify 1/2 x to the minus 1/2, I could write that as 1 over 2x to the half, then minus x to the half, and then over x minus 3 squared. I'm not real sure that I made that better. Let's switch back to the square roots and get rid of these fractional exponents and see if the way to simplifying this becomes a bit more clear. So this is going to be x minus 3 times 1 over 2 root x minus root x all over x minus 3 squared. All right, so we had a trick when we were doing limits that had complex fractions in them to clear out those fractions, and I'm going to use the same trick here. I'm going to multiply everybody on top and bottom by 2 root x. So I'm going to do it once on top. We'll distribute it to everything up there, and then 2 root x, and we'll see what happens. So there's 1 here, and then 1 goes to this entire term right there. Okay, so when I multiply on top, I get x minus 3 times 1 over 2 root x times 2 root x. This is going to be the whole point of doing this, that these 2 root x's are going to cancel out. And then I've got minus root x times 2 root x all over the denominator squared also gets multiplied by 2 root x. I'm going to put that out front. And that denominator is not going to get any prettier, but up top we'll get a little bit. So I got the only thing that's left in the first term is x minus 3. In the second term, I've got these root x's that are being multiplied. And when you multiply root x times root x, it's root x squared. You're just going to get an x. And so that actually cleans up nicely. I get x minus 3. Now that the two root x's are gone, I don't even need the parentheses around that anymore. And then our second term was minus, there was a 2 buried in there and an x. So minus 2x all over all this stuff in the denominator. And then I can actually simplify these x's in here. I've got an x and a minus 2x. I can combine those to be a negative x. So I've got negative x minus 3 over 2 root x times x minus 3. It's kind of tempting to try to cancel out those x minus 3's, but since the top one has a negative x and the bottom one has a positive x, we can't do any simplification. We're just done with this one.